Hello viewers, in today's session we are going to discuss this integral. So here we have to evaluate the integral from minus infinity to positive infinity, and the integrand is e raised to negative of absolute value of x plus 1, right? So let us call this integral as I. So now in order to evaluate this integral, we have to make use of the definition of modulus function, right? So now see, the modulus function is defined like this: mod of p is equal to positive p whenever p is greater than or equal to 0, and mod of p is equal to negative p when p is less than 0, right? So here our integrand is e raised to negative of mod of x plus 1. So let us first define mod of x plus 1 using this definition, right? So replacing p by x plus 1, we have a mod of x plus 1 is equal to positive x plus 1 whenever x plus 1 is greater than or equal to 0. So from this inequality we have x greater than or equal to negative 1, and mod of x plus 1 is equal to negative of x plus 1 when x plus 1 is less than 0. So we have x less than minus 1. So here we have the real number line minus infinity to positive infinity, and here the lower limit is negative infinity and the upper limit is positive infinity. And here we have the critical point for mod of x plus 1 is given by negative 1, right? So here what we will do, will split this integral I as a sum of two integrals, right? And this is the point, that is x is equal to minus 1, where we split this integral into two parts, right? So I1 is given by minus infinity to minus 1. So first we'll write minus infinity to minus 1, and here we have e raised to negative of mod of x plus 1 dx, and then we have I2. So I2 is from minus 1 to positive infinity. So we have minus 1 to positive infinity, and here we have e raised to negative of mod of x plus 1, and here we have dx. So when we go from minus infinity to minus 1, then we have here x less than minus 1, right? So when x is less than minus 1, then mod of x plus 1 is negative of x plus 1. So here we'll replace mod of x plus 1 by negative of x plus 1. So we have minus infinity to minus 1, and we have e raised to negative. Here we have the negative sign, and then we have negative x plus 1, and here we have a dx. And when we go from minus 1 to infinity, then we have x greater than minus 1, or x greater than or equal to minus 1, right? So here we have minus 1 to infinity and e raised to negative of mod of x plus 1. So in this case, mod of x plus 1 is positive x plus 1. So here we write positive x plus 1, and here we have dx, right? So now we can write minus infinity to minus 1, and here negative times negative, that is negative multiplied with this negative sign, it becomes positive. So we have simply e raised to x plus 1 and dx, and here we have minus 1 to infinity, and e raised to here we have simply minus x minus 1 and dx. So now we can write here minus infinity to minus 1, and here we can write e raised to x times e raised to 1 and dx, because the exponential function, it follows the rules of exponents, right? And here we have minus 1 to infinity, and here we have e raised to minus x times e raised to minus 1 dx. So now here we can take e outside the integral. So we have e and minus infinity to minus 1 e raised to x dx, and here we can take e raised to minus 1 outside the integral, minus 1 to infinity, and e raised to minus x and dx, right? So now we have I is equal to e. Here we have e, and the integral of e raised to x is simply e raised to x, and the limits are from minus infinity to minus 1, and here we have e raised to minus 1, and the integral of e raised to minus x is negative of e raised to minus x, and limits are from minus 1 to infinity. So now here we have e, and now we can substitute the limits. So here we have e raised to minus 1 when x is equal to minus 1, and when x tends to negative infinity, we have here e raised to minus infinity. And then here we can take this negative sign outside. So here we have minus e raised to minus 1, and here we have now e raised to minus infinity, because when x tends to infinity, we have e raised to minus infinity, and then we have minus e raised to plus 1, because here x is a minus 1, and minus it becomes positive, right? So now here we have this term, that is e raised to minus infinity, right? And e raised to minus infinity tends to 0, because we know that when we have e raised to x, and when x tends to negative infinity, then e raised to minus infinity, it tends to 0, right? So here we can replace this term by 0 and this term by 0. So we have e, and here we have 1 over e, and here we have 0, then here we have 1 over e, and here we have 0, and here we have simply e, right? Where e is the exponential number. So now here we can simply write e times 1 over e, and here we have minus 1 over e times minus e, right? So here e and e get cancelled, so we have 1. Here e and e get cancelled. Here minus 1 times minus 1 is simply plus 1. So we have 1 plus 1 is equal to 2, right? So the value of this integral is equal to 2. So this is how we can find out the values of these kind of integrals using the definition of modulus function.